Good afternoon, everybody. My name is Debashish. I'm the senior technical trainer at the Indian Cyber Security Solutions, and these are the contacts of my Twitter and LinkedIn in case you want to contact me. Today, I'm going to discuss about the types of routing. So let's start. Now, first, I'll discuss what is routing is all about. See, routing is a process to send data packets from one location to another location across WAN links. So if one location means one city is connected to other city by routers, then through that WAN link, we are going to send packets from one city to another city. That is a routing. Routing is configured between two different classes of networks or subnets. Yes, that is very important because in LAN, if you have two different LANs in two or more different cities, then what happens that you can have two different classes of networks, say class A, class B, or class A, class C, or class B, or class C in either end. And you can have different subnets also, say 10.0, 20.0, 30.0, these different subnets. So to connect in between these networks, you need routers. A layer 3 device called router is needed for routing, definitely because layer 3 means what? Means network layer device, not data link layer. It is network layer device, means the in the OSI model, the layer 3. Because the IP routing and the IP addressing all are part of the layer 3 or the network layer. Now, let's come to the types of routing. See, the routing, it is of two types. For example, one is static routing and the other is a dynamic routing. Now, what is static routing all about and what is dynamic routing? Now, first, let's discuss the static routing part. The route from the source to destination network is configured manually in case of static routing. What does it mean? It means that if you want to send packet from source A to source B, then you need to just configure the route manually from the source to destination network. The entire route you have to configure it manually, and the router will route the packet through that route only. Static routing is faster than dynamic routing because in case of static routing, you do not need to process any routes. The router does not process the routing path. So the path is already predefined. So in that case, static routing is faster. So this is the advantage of static routing. But there is a downside also. There is a disadvantage of static routing. What are those? That it is difficult to maintain many static routes at once. If you have 10 sites, then it's possible to maintain static routing. But say if you have 100 sites, 100 locations, then if you have 100 static routes, then is it possible to maintain so many routes? Because the destination network may change anytime and you have to remove the static routes and again you have to configure the static routing. So that is a bit problematic part. It's a time consuming part also, and administrative burden is much more. So what is the solution? The solution is dynamic routing. Dynamic routing, as it said, is an automatic process. What does it mean? That yes, you have to configure it, but you have to configure only the source network part, not the destination network. Means, say, I'm describing it. Say, this is a location, this is location A, location B, location C, and D. So here, your objective is to go from A to B. Now the path can be through C, also can be through D. So if you configure static routing, then you have to configure the path manually either from this to this the direct link. So if you configure this and this LAN is 20.0 network, so in that case, you have configured that from, say, for example, from this 10.0, you can reach the 20.0 through this path. But in case of dynamic routing, you have different options. You can go through C or you can go through D. So it depends on certain conditions, certain routing protocols. Some routing protocols take bandwidth as a consideration to decide the metric for the selecting the best path and the forwarding decision, that I should say. And some routing protocols like OSPF, open shortest path first, it takes the cost in consideration, and cost is related to the bandwidth part. So that is the different metrics that routing protocols use. And BGP, border gated protocol, they use very complex metrics, different metrics. So many different metrics are used by dynamic routing protocols to select the best path, select the forwarding decisions. So the packet may take this path or the direct link. So in case of OSPF, say for example, if this link is say 4 Mbps, this is 2 Mbps, and this is 1 Mbps, then OSPF will prefer this 4 Mbps link always because it is of highest bandwidth. And in case of EIGRP, it will take the least bandwidth link, 1 Mbps. These are the different criteria that dynamic routing protocols use to send packets. So this processing happens inside the router process, and for that, the processor overhead is much more in case of dynamic routing. Best path forwarding decision is taken by routing protocols that I've already told you, and only source networks are configured. So you have to configure only source networks, not the destination network. The destination network path is decided by the routing protocol itself. So you do not need to configure that. And also, you do not need to send the subnet mask information with the routing updates. Because in case of static routing, you need to send the subnet mask information because you are configuring the route manually. But in case of dynamic routing, the router is itself, it is processing the destination network according to the metrics. So we do not need to give the subnet mask information. And this dynamic routing is suitable for large enterprise networks that I've already told you, because in case of static routing, it is difficult to maintain so many static routes. But this dynamic routing also has some disadvantage, that dynamic routing is slow compared to static routing because it involves so much processing that the overhead on router processor increases with more number of routes. So dynamic routing is slower, but it is also advantageous in case of large enterprise networks. So these are the types of routing that I've already discussed with you, the static routing and the dynamic routing part. And I can also show you how to configure the static routing in Cisco Packet Tracer. So in Packet Tracer, just take two routers, connect it to serial cable, take two pieces, go for the connections, then give the IP address, the clock rate, the DC part, say 192.168.0.1, and for the fast Ethernet port, give the IP address, say N001. Always keep the default silent mask in case of static routing. On router B, the serial port give the IP address, say 192.168.0.2. And on passing hand port, say 20.0.0.1. Now, to configure the static route, IP space route, and the destination network is 20.0.0.0, and the subnet mask is 255.0.0.0, and the default gateway, that is the IP address of the router's B's serial port, that is a 192.168.0.2. And on router B, also come to the remote IP space route. Destination is 10.0.0.0 mask, and default gateway is 192.168.0.1, the other router serial port. And give the command to IP route to the static route. See, this is a static route 10.0.0.0, it is connected. So this way you have to configure the static routing. And you can also give the IP address to the basis also 10.0.0.2 and gateway 10.0.0.1. Gateway 20.0.0.2, 20.0.0.1, and you can send also packets. So static routing is working. And if I change it to the dynamic routing protocol, say OSPF or EIGRP, so first we have to remove the static route because the AD value of static route is 1. It is lower than any dynamic routing protocol. So if you configure dynamic routing protocol, it will not show. The static route will always show. So first, remove the static route, no IP route on both the routers. Now let's implement OSPF. Or you can also implement EIGRP also. So let's configure OSPF. Router, OSPF, first ID 1, then only the source network. Source is 10.0.0.0 mask. Another is 192.168.0.0. And on router B, site it can be anything, it can be 1, it can be 2 also. Meta would be 20.0.0.0. And you have to connect it to the backbone area 0. And again 192.168.0.0 and the wildcard mask. So this way you have to configure the OSPF and see it has already taken the neighbor relationship to OSPF. And you give the command to IP route. You can see the OSPF route there as well as on the this router 0 also. Okay, it's there. And already PCs are configured. So here also you can send packets from both the PCs successfully. So we have, yes, it's successful. So we have seen how to configure the static routing as well as the dynamic routing protocol. And I've already discussed with you the difference between static routing and the dynamic routing today. So that is for today. And I think it was informative for you and you enjoyed it. And so for now, for today, that's all. And on some other day, we'll discuss some other topics. So for now, it's goodbye.
So there is a question coming. So which routing is widely used?
Thank you. Okay. One question is coming that which routing is used widely, static routing and dynamic routing. See, The static routing that I've already told you, it is not used so widely because of its limitations. Like it is, it is difficult to maintain and configure the static routing if there are too many static routes. If it's fast, but it is difficult to maintain. So dynamic routing definitely is used in large enterprise networks. So it is processor incentive, but it is used in large networks. It may take some time. It's a bit slower, but it is used in large enterprise networks. Okay, so that is, I think it's clear that dynamic routing is used more than static routing in case of large networks. Somebody has asked me about the clock rate that I've used. Clock rate is a command used in the DCE part, that is data communication equipment. DC, it is used in that ISP router, and ISP internet service provider is giving us a WAN connection, and their router is called the DCE router, and our router is called the TTE, data terminal equipment. Okay, and in that case, in that ISPN, in the DCE part, the clock rate is used to synchronize the signal between the customer router and the ISP router. And the clock rate, there are many clock rates. We usually use the clock rate 64,000, but it can be 120,000 and it can be beyond that also. But some routers do not support higher clock rates. So in case of Cisco CCNA part, it is better to use 64,000. Okay, so I think it's clear to both of you. So thank you all for watching this today's session. Thanks of all. Thanks. Bye.